floating point numbers, which is confusing.
Yeah.
There's positive and negative 0. So speaking of floating point numbers, what do we know about floating point numbers? Not an integer. So what's the difference between an integer and a floating point number? Exactly. The floating point has a decimal place. Okay. So anything we need to know about floating point numbers?
Be careful when you add subtract, or when you use any kind of multiplier, unless you're rounding them off to a particular decimal place.
Right, because they're inexact, right? They're not completely exact. So there's a bit of, particularly when you use equal equal, there's a little bit of danger. So can you guess how programmers work around that problem with floating point numbers? In other words, when I do, you know, if I have 1 equal to 2, but these are floating point numbers, or like I'm trying to do that, but they're floating point numbers, and they're not exact. So this might be 1.0000001 and 1.0000002. But so how do I know? How do I do that? Can you guess how programmers tend to do it?
I would guess you turn them into integers by multiplying them times a certain 10 or 100 or whatever in order to get the right number of decimals you want, then take a floor function, or add, or if you add a half, 0.5, take a floor, and then you can turn back.
Yeah, that's certainly one way to do it. The downside of that approach is this ends up being true, and that's no good. And so actually what people tend to do is they take the two numbers, subtract them, find the absolute value of that, and then compare that to a really, really small number, right? Like they're called sigma, and then, so you're seeing if they're within a certain, so if you have to do that, okay? That's how you tend to do it. Does everybody follow what I was trying to say there? You would do something like, I think it's
ABF.
Yeah. Yeah. Okay. That's how you would do that. And then you would know that the numbers, they're not exactly equal, but they're for your, you know, your concern, they're equal. That's how you would do it. And you can make this whatever you want, right? You know, if all you care about is to the hundredths, you might say, that's good enough for me, you know. Or you might put a whole lot of zeros or whatever. Okay. So that's floating point numbers. Something we've not covered with floating point numbers is how to, we saw print line, prints them out. And it kind of does it's clever the way it does it. So if the number is really close to being a whole number, it just prints just the whole number. But if it has a lot of extra digits, it'll print them. So one thing we would like to know is how to format the number to make it, you know, I want to have hundreds, I want to have, you know, thousands. I want to show it with a specific format. And so the way we can do that is using, in the format library. So if we go godoc.org/fmt, we can use these, which we saw before, these special format strings, and one of them is specific to floating point numbers. And so we can see here, here's scientific notation, here's decimal point with no exponent, so 123.456. So if we wanted to do this, right, we wanted to put it in this format, it turns out you can put before that letter things like this. So we have %f, default width, default precision. That's what does it, you know, 2 digits or 3 digits or 5 digits, it's automatic. But you can put a number, so width 9, right? Or you can put the decimal place, 0.2. So let's try some of those out to see what they'll do. So instead of print line, we say printf. Okay, and then we give it a format string and our number. And we run that. Right? And it just did a default, whatever it thought was best, 1.23. So let's say we only wanted to 2 decimal places. Let's see if that works. There we go. Okay, so what I did is I added this 0.2. Now the 0 here is interesting because it fills it with zeros. So if I just did that, I think it's going to get the same answer. Yeah. But the difference being, if I had like a big number. So, anyway. So you can format the floating point numbers using this. And this comes from printf and C. So if you're familiar with that, it's the same kind of idea. And look at the examples. There's a lot more examples of how to do it. But basically, you're going to tend to only use a few of these, right? Now I have 6 decimal places. But basically, that's how you're going to do it. If you need to format floating point numbers, use printf. Okay. Now, if you need to put it into a string, you can use sprintf or string printf. So it's sprintf. And that will create a string. So, and then you could print your string. Whoops. It's the same thing. The little arrow here, that's just this shell telling you it didn't have to do that. But so, some terminals, if you didn't do that, it would like put the prompt right here. So it would be kind of confusing. It put the text right before your prompt, which would be hard to read. So it was just indicating there was no new line. In this case, there was because it used print line. So if you in printf, you can also put /n here. Okay. So anything that's not related to that percent whatever formatting will just be printed verbatim. So I can say, this is my number. And then what it's going to do is take the number and put it in that place inside of the string. Okay? Everybody following?
Where can you get these shortcuts on the internet?
Yeah, so if you go to godoc.org/fmt, it describes the rules here. It's going to take a bit of work to read through them because they get really complicated, but they describe them in exhausting detail. And there's all these other things it can do, right? You can fill it with zeros, you can fill it with spaces, you can fill it with all that stuff. But yeah, that's what you need to do. Basically, you pretty much only use the point whatever, and maybe you use the padding. Occasionally, the padding is handy because let's see if that is the right way. So it added some extra spaces before the number. And so say you had like 50 numbers you're trying to print out, and you want them to all be sort of right aligned, and so they all are nice and pretty in tabular format, you can use that width to define that, okay? And then if one's like 1 and one's like 1,000, it looks nice, okay? Because otherwise it would, it would put it here and then it would all go off this way, and that would be confusing. Because you want your decimal places to align. For people. Okay, so that's how you print floating point numbers, and we've just seen an example of how you convert a floating point number into a string. You use printf. Okay. There's other ways to do it too, but that's an easy way to do it. Okay, so that's floating point numbers. So that's basically what we've covered as far as types go. Any questions about types? We're going to see more advanced types today.
I'm sorry, well, one last review. The difference between equal and colon equal is colon equal, you don't need the bar.
That's right. Because colon equal, it's, the colon's like adding the bar behind it. So colon equal is create a new variable and give a value. Equal is just give this variable a value.
And use colon equal inside the main, not outside of it.
That's right. Use colon equal inside of functions. Outside of functions, use var.
What was the meaning of the Todd's note here? Strings are represented in computers UTF-8.
Yeah, so UTF-8 is the encoding of the string. And that's just saying that it uses ASCII, and then for things that aren't ASCII characters, it's going to use a multi-byte encoding to represent them.
That's the same thing we said as the car set on the top of HTML pages.
Yep. It's the most standard, sort of easiest encoding to use. And so one advantage we'll see later when we start working with web stuff is that Go plays really nice with that because we don't have to do any conversion. We just dump it and it's good. Because UTF-8 is sort of the standard everybody's using. So Okay, so those are types. We did variables and types. Control structures. All right. So I'm going to go to the end here. What were the various control structures we talked about? So if I want to do something a bunch of times, what would I use?
For loop.
For loop. So what does the for loop look like? Can somebody show some of the various types of for loops we can make? Let's do the easiest one. How do we do an infinite loop in Go? A loop that never finishes, just runs forever. Yeah. We've got all these people editing at the same time. Yeah, so we could say for true, that would work.
Give a very nice laugh, by the way.
You could also just leave out the true, and so for with nothing is a loop forever. Okay. So if you want to, you can read that forever.
Forever. It could be if we all.
So if we want to loop on a condition, how do we do that? Okay, so that's how this is how we're going to do a loop of a fixed size. Okay, so I know I want to do this 10 times. And notice when we want to do something 10 times, we start at 0 and we use less than. Okay. If we wanted, we could start at 1 and do less than or equal, but we typically start at 0 and do less than. So in other words, I in this case will never be 10. It finishes at 9. Okay. Following? Because of the less than. That sometimes throws people off. They go confused about that. That's an infinite loop.
So can I just clarification, the 10 there, when it reads that I less than 10, it's reading according to the index, counting 0, correct? That's why it stops at 9, not using equal, less than or equal?
Yeah, so what happens is, if you take out this I minus minus, if you go from 0, it'll start at 0, it says yes, I is less than 10, and so then it goes, executes this code, and then it does I plus plus. And so now I is 1, it does is I less than 10. It'll keep doing that. By the time it gets to 9, then it runs the code, and then it adds 1, and then it gets here. 10 is not less than 10, so it finishes. Okay?
So it has nothing to do with the indexing that it starts from C. Well, the code's written 0.
Yeah. Yeah, so.
I'm looking at it. I got it.
Yeah. So, no, the point is that this code runs 10 times from 0 to 9. Okay? Not from 0 to 10, from 0 to 9. And those, that's one of the most common mistakes in programming, and you will find it all over the place. Like it's the root of so many bugs is off by 1 errors. Okay, you thought you did it 9 times, so you added 1, and you actually did it 10, and you made a mistake. Okay, that's super common. So if you make that mistake, don't feel bad. Everybody makes that mistake.
The way it's written now, it's just going to go forever.
Yeah, I was saying that with this statement, it is actually the loop because it starts at 0, goes to -1, then goes to 0, and so it's just never going to finish. Okay. This is an interesting example. So typically when so this would be the more typical way. You have a variable, and the having fun here is, is a Boolean. This would be, and then inside of your loop somewhere you would change it. Okay. If you never changed it, this is the same as an infinite loop. So you probably are inside of this loop somewhere going to change having fun to false at some point. Okay. Now this case where you say equal equal false, that's pretty unusual. Okay. Typically you never do equality with true or false, right? Because equal equal true is the same as just leaving it off, right? Is true equal to true? Of course it's equal to true. That's obvious. So you would just normally leave it by itself. If you want to say is it false, you do exactly. You use this, and that's the not operator. Okay. So if the credit card is not maxed, right? That's the idea. So instead of saying equal false, you use none. Okay.
Making sure.
And the corollary to the equal is the not equal. I'm not sure we saw that. I know some people here were using it, but you can say x not equal y. And you can think of this as the equal, you know, when you see this, think of it like this. That's what you're doing, right? And the reason why we don't use that symbol, even though it exists in Unicode, is because it's not on your keyboard, okay? So we use the symbol that's on your keyboard. This kind of looks like that, and that's why we do it.
That's good. I never thought about it.
Yeah. Well, actually, there's a lot of these symbols which aren't great, right? Like, why don't we use that special division, right? We use slash. Why don't we use, you know, we don't have a character for it, so that's why we use it.
We need a programmer's keyboard.
Yeah. Okay. So those are the basic loops. We also talked about another for loop, didn't we? With strings. Does anybody remember that one?
That was like the range.
Yeah. Can somebody show me what that one looked like?
Alright, what did I do wrong?
Okay, so range comes before, not after. This is an interesting question what that's going to do. So let's try it and see. I don't know if this is actually going to work. That's interesting. Totally works.
So it's based on the length of the string.
Yeah. So if you don't put anything before it, it's just going to execute this loop the length of the string times. Okay. So that loop would be basically equivalent to okay. That's basically the same exact loop because that's what's happening.
So if you ask it to print whatever letter is in that particular I,
Yeah.
it would print that letter. It would print all the letters in the word. You could do that up above like a range.
Yeah, so the issue with what we did with this one is we don't have access to that character. And so, does anybody remember the form of the, if we want the index and the character, how do we do that?
Or I range something.
Yeah, somebody want to try it?
I don't know where I'm at. He's all you.
For I, and then, yep, okay, perfect. Did you guys like do that at the same time? That's great. Cooperative programming there.
That's pair programming, baby.
So for I in range something, this is going to print what's I here each time.
Looping through,
Oh, yeah.
starts with 0 and loops through
Exactly.
the number of letters.
So it's 0, 1, 2, 3, 4, 5, etc. But if we want the character, if we want to print SOMETHING, what do we do? How do we change this?
Fragments? No? No.
So there's an alternative form to the range. You can say comma C. And so this is the index, and this is the character. And this is actually going to print the number of the character.
So range is only work on a string, not on a numeric value or an.
That's right. Ranges don't work on integers or anything like that. They do work for arrays, slices, maps, channels. We'll talk about that. But they don't work for integers or floating point numbers. So if we don't need I, what can we do? If we just don't care about I?
Underscore.
Exactly. Use underscore. Okay, perfect. And the reason we cover this again is we're going to use this range a lot for other things, but not so much for strings. Okay, so that's a for loop. We did the fixed length for loop where we use I as an index, and we did the range, and we did the condition for loop. We'll see the other versions of the for loop later. But that's basically how you loop in Go. There's no while, there's no do, there's no until, there's nothing else like that. We just use for. Okay, so there are two other control structures we talked about.
Switch.
Switch is one, and the other one was
Case.
Not a part of it.
if. Exactly.
Oh.
So, what does the if look like? Does anyone know right out an if?
Sorry, I'm muted on. There we
So we have if 1 equals 1, and then inside of here are your statements. And those statements only execute if the condition is true, right? And then you can have multiple statements, multiple expressions, and you use else if for the subsequent ones. And then the final one can be else, okay? So you have if, else if, then else, and that's the form. Now else and else if are optional. You don't have to add them, you can just add it if you want. Okay? The other thing about if that's important, well, one is we don't have parentheses, okay? And most languages you do. Other things that are important about ifs here, these expressions, what's in here, like this if false. If I did we haven't covered functions, but we invoke functions. So I'm invoking some really long name for a function, but something which doesn't, maybe it prints to the screen or something. This doesn't happen if the first condition happens, okay? This only happens if it doesn't, okay? And so, just remember that, that's another important. And the stuff inside of it also doesn't happen, right? Because it never gets to that branch. Okay. What else can we say about ifs? Right, so you can do expressions like this, you can call function, you can do anything that is an expression. And once again in the spec, expressions are detailed. There's a lot of kinds of expressions. So here they are. They can be operands, which are like literals or variable references. They can be, there's all kinds of stuff. And so use expressions a lot. So statements are made up of expressions. Expressions return a value, and so, or more than one value. You can use them as part of your if statement. Okay. So I think we saw an example of how to use them yesterday. Ifs are pretty straightforward, very similar to their cousins in other languages. The other one we talked about was switch.